All right, so our first thing that we're going to talk about when it comes to statistics is looking at categorical data. All right, so let me just give you a brief kind of introduction into one of the first things we talk about in statistics, and that's talking about the two different types of variables. All right, there are categorical variables, all right, categories, all right, and there's also quantitative variables. Okay, quantitative variables are variables that have units, all right? Variables that have units, right? So a variable that is quantitative for us would be like our age, the age in this class, right? You guys would write down your age in years. So the units would be years. All right, so when you're trying to decide, is this a quantitative variable or is this a categorical variable, ask yourself, what are the units? If you cannot think of any units, then it's a categorical variable. Okay, thinking there are two options, all right? Usually yes or no, all right? Or sometimes there's more than two options, but they'll give you a list, right? Have you guys ever filled out a survey online and you click on a dialog box and it gives you a bunch of like options to pick? All right, that's a categorical variable. You've got to pick one of those options, okay? When you can type in your own thing, right, in numbers, usually that's a quantitative variable. Okay. So the way that you need to be comfortable with this for the SAT is understanding these tables. These are called two-way tables. The reason they're called two-way tables is because you have two categorical variables. So this table that I've given you right here, just as an example, is real data from the Titanic. I think you guys are all familiar with the ship, the Titanic, that sank over 100 years ago. Yeah, I think it was 1919. Okay, so... Was it 1912? Oh, thank you very much. See, I didn't even know. All right, so definitely over 100 years ago. Thank you, Lissandra. So if you look at this, all right, you can see, all right, based on did they survive, right? So alive or dead, those are the categories for survival. And then the class of their ticket, were they first class, second class, third class, or were they actually working? They were part of the crew, okay? Does everyone see the numbers that are on the outside, underneath this total column and this total row? Do you guys see those numbers? All right, those are called marginal distribution numbers. Okay, you're not going to need to know that word, all right, but I just want to say it to you because if you ever hear that word or you take stats in the future, all right, anytime you look at the numbers in the margins, that's called the marginal distribution. So the marginal distribution of survival is 711 people survived, and 1,490 people did not. Okay? So that's the marginal distribution. We're going to need to know those or calculate those to do some of these problems. Okay, what you're going to find when we do these problems is that the most challenging problems, all right, the most challenging problems on the SAT are when they give you conditional probabilities or conditional percentages. All right, so looking at not just out of the total, but out of, like, let's say, out of all those that survive, how many were in the second class. Okay, so you're going to have to figure out, based on the statements, what part of the table, bless you, what part of the table are you going to use? All right, and so you're going to find that the next 2.5 weeks is going to be a lot of reading. All right, a lot more reading than you've ever done in math. Okay. Now, I'm going to say this, but you don't need to know this for the SAT, because one of the next steps after this is looking to see if there is a relationship between these two variables. Okay, so basically, if we're thinking about the Titanic example, is there something going on? Is there a relationship between whether you died or not and your ticket on the Titanic? So you guys have all read about it or even seen the movie. What do you think? Do you think there's a relationship between whether you died and your ticket on the actual ship? What do you think? Who's got an idea? No ideas? Issa, you're nodding? Yeah, what's your idea?
First class was saved first.
Okay, so Issa thinks that the first class passengers, which are the wealthier ticket, that they were saved first because they paid more money, the rich people got saved. Fair enough. All right, that's definitely a theory. Let's look at graphically this table. Okay? Now, this is by percentage. All right, so if you look at the one for alive or survive, you can see the first class, and actually the crew had the biggest percentage. But keep in mind, do you think there were more first class or crew on the Titanic? Probably more crew working the actual ship. All right, so even though these look similar, all right, in terms of the percentage of people, a lot more in the crew died. Now look at this column here, that bar chart. Do you see how it's different? Right, when you look at the first one to the second one, whenever you see a difference in those bar charts, you know that there is something going on. So EC, you're correct. All right, there is a relationship between your ticket and whether you died, and if you had a first class ticket, you're more likely to have survived. And if you had a third class or crew ticket, or I guess crew didn't have a ticket, if you're working it, you're more likely to have died. I mean, look at that percentage for dead. Over 80% of those that died were third class or crew. Okay? Now, you're not going to have to do that for the SAT, but it will be something you do in statistics if you take that course. Okay, so let's try some problems. Let's show you what this is going to look like on the SAT. So what I've done, if you flip it over, is I've given you a table, all right, and we have two categorical variables. All right, we have two variables. The first one is origin of a car. All right, so in this case, American is an option, so made in America. European, so made in Europe. Or Asian, made somewhere in one of the Asian countries. Okay, then I've also given you the variable driver. Are these cars driven by a student or by someone who works at this university? All right, and one thing I notice about this table is it's missing what? What is this table missing? Somebody said it. The totals, right? And if you want to say the actual vocab word, go for it, Danny. Oh, sad. The marginal distribution. It's missing all of the rows and columns for the totals, like Zach said, but those are called the marginal distributions. So let's write total here and total underneath. You can use that yellow calculator. We can find some numbers in the margin. All right, so let's find first, how many total American cars are there? How many total American cars are there? 212, very good. Okay, how many total European cars are there? 45, excellent. How many total Asian cars are there? 102, okay? Now let's go to the other variable, the driver classification. How many total student drivers are there? How many total student drivers are there? 195. And then finally, how many total staff or employees of the university? How many total drivers there? Okay, now, before you move on, because you found the marginal distributions for each of these variables, I want you to get the grand total. Right, how many total in all? So you actually have two options here. You can add up these three numbers in this column, 212, 45, and 102, or you can add up these two numbers in this row, 195 and 164. And one thing that I like to do is I like to do both and confirm they're the same number. That way I don't have a mistake. All right, so why don't some of you pick the column and some of you pick these two numbers in the row. See if you get the same thing. Did you get one, Katya? Which one did you do, the row or the column? Oh, you did both and you got the same thing. Okay, all right. Which one did you pick? You did, okay, sorry. Keep calling, people did both. Cynthia, which one did you do? You haven't done either. Okay, well, there we go. Other end of the spectrum. Isabel, which one did you do? The column. What'd you get for the column? 359. Did anyone do the, you did the column, sorry, you did the column? Who did anyone do the row, the two numbers down here? Amy, did you get 359? Excellent, good. Okay, so once you have your marginal distributions written down, now you're ready to try to answer some of these questions. So let's read letter A. What percent of all the cars surveyed? All right, so when I first read that, of all the cars surveyed. So how many cars were actually looked at in this survey? 359, very good. So my denominator is going to be 359, right? Of all the cars surveyed. And it says were foreign. So what does it mean by foreign? Not American. So when I look at my marginal distribution for origin, which of these two numbers would be not American? 45 and 102. So I'm going to put those in the numerator with addition. All right? And that is 45 plus 102 is 147 over 359. So if you go ahead in your calculator and do that division, 147 divided by 359, you get 0.409. Now that is the decimal version, 0.409. So what is the percentage going to be? 40.9%. And that is the answer. Okay, who has any questions about A? Because you may not have done a problem like this since you were in middle school. Yes, Aaron. So all I did was once I had the calculator set 0.409, I moved the decimal over in my head 2 places. So 1, 2, so 40.9%. If you want to actually do it in the calculator, just put times 100. Yes, because percent means per 100 in Latin. Okay, Amy. Yes, always to the right. Now, if I had this number, Amy, if they gave me 40.9% as a decimal, then I'd go 2 to the left to get the decimal. That's how you always do percents of decimals. Yes? You good? A little. Why don't we try another one? Let's read letter B. What percent of the American cars? So let me read that again. What percent of the American cars? So when I look at that, what is my number for the American cars? So that is going to be my number in the denominator. So you'll notice that the way I do this is I always try to find my denominator first. So what percent of the American cars were owned by students? So again, I'm just looking at this row. How many are owned by students? 107. So that's my numerator. All right, so in your calculator, do 107 divided by 212. And you get 0.505. So as a percentage, that's going to be 50.5%. Okay, Amy, all good with that? No, what's up? You said, yeah, my bad. Bless you, Zach. Yes, David. Yes, so always round to the nearest tenth, hundredth, thousandths place. All right? Because when I looked at the SAT problems, that's where they rounded the most, was to the thousandths place. Okay? All right, let's try part C here. What percent of the students? What percent of the students? So I'm looking at of the students. How many students were there? So that is my denominator. What percent of the students owned American cars? So just in this column, what percentage owned American cars? So what number is going to be the numerator? 107. You'll notice once I pick a row or column, I don't move from that row or column. The most common mistake I see when students start to do this is they'll get the denominator right, but then they'll go, oh, American cars, and they'll put 212. And now you've got a bigger number in the numerator, which should never be happening. Okay? Your numerator will always be smaller. So once you pick whatever row or column, whatever variable they want you to focus on, stick to that row or column. Okay? 107 divided by 195. I got 0.549. Excellent. All right, so I'm going to write 54.9%. Okay, who has questions on this process? Because, guys, basically this is it. If you can do this, you will get these questions right on the SAT. Yes, Amy. Uh-huh.
Percentage thing, so say one thing like 54.8.
Well, you should have rounded. What I've noticed with the SAT is they don't do that. Like, they wouldn't have an answer choice that said 54.9 and 54.8. It's like 54.9, 47.2.
So close to the answer, I guess they're going to count it off.
If you get that point where remember, it's multiple choice for almost all of them. So if it's multiple choice, just pick the one that's nearest to what you got. All right. In terms of the write-in, then yeah, they probably would count it wrong. All right, but what I've noticed with the, sorry about that, what I've noticed with the rules they do